Hi, class. So I just wanted to go over statistical significance again in SPSS. So the first thing we're going to do is we're going to go to our tiny URL week 401A week 2 data. That's the sleep apnea data set that if you decided to do the optional survey, a survey analysis lecture I prepared, then you could do that. But we're just going to continue using that. So I want you to go and import the data. And what we're going to do is we're going to compute some categorical variables. And what we're going to do, we already have a gender flag for whether or not an individual is listed as male or not. What we're then going to do is create a new categorical variable called the number of pillows. And that is, again, we're working with a sleep apnea data set, and what we want to see is whether or not the number of pillows that an individual uses might potentially affect some of the outcomes we're concerned with. And if, as you note, if we look at this data set, and we go into, and you open it up on your own, you will see that pillows is a continuous value, and we want to convert that into something that is a little bit more sensible in terms of, for our analysis. So what I'm going to do is I'm going to use the round function. So we're going to cast these things as integers by rounding it, and we're going to multiply it by 3 just so that we'll have multiple integer categorical values that make sense. Okay, so we're going to go to transform, we're going to press OK, and we're going to change the existing variable. And what we're going to do is we're going to look at the data editor real quick and see how that translates. Okay, that seems reasonable. So we had our number of pillows originally be something like this. It was a uniform random variable, and now we have something that makes a little bit more sense, that individuals seem to use 0 to 3 pillows when they sleep at night. So the first thing we want to do is we want to just, again, we're interested in sleep apnea, as well as some of the other features. So we have this measure called sum score, which corresponds to how an individual performed on one of those sleep apnea assessments I told you about. And what we're going to do is we are going to see on average the cut point that medical researchers use to identify whether or not someone is suffering sleep apnea is whether or not they have an average sum score that is greater than 15. And we're curious about whether or not our population of users, our population data set is greater than that. So what we're going to do is we're going to go down to compare means. What we're going to do is we're going to do one sample t-test. And what we're going to do is we're going to do sum score. Our test value is 15. We're going to click on our options. Okay. In reading this, what it presents is we've generated the underlying sum scores, their mean and associated standard deviation, and we also have the associated standard error. And what we see actually is that not only is our test statistic quite different quite large. We have a t-statistic of around 9.5, and that is associated with a probability of 0, or a p-value that's almost 0, meaning that there's a very large difference between what our test value was and our true population mean. In fact, we can see here is that the average difference is around 7.3. And even when we look at our confidence interval, we see that the true difference probably ranges somewhere between 5.8 and 8.8. Now, what happens if we were to do this with a slightly larger confidence interval? Would we still get the same results, or would we get a wider confidence interval? Well, there are a couple of ways we can do this. But let's continue using this one sample t-test. Okay, we're still going to use that test value of 15. And now let's try going to 99%. One of the things I want you to notice is that our range when we used 95% as our confidence interval was 5.8 to 8.82. And what we're going to see what happens. Let's do 99.9. Okay. And we're going to press OK. And what do we get? We see what's changed. Well, our summaries, our one sample statistics haven't changed at all. Our standard errors haven't changed. Our associated t-statistic hasn't changed. And in this case, the p-value hasn't changed, and nor has the mean value difference. The only thing that's changed is our confidence interval. And just generally, as you can see, it is that as you use larger confidence intervals, the range of values that you will that your null hypothesis will accept becomes larger and larger. In this case, the difference was so large that we didn't even see. We still reject our null hypothesis, even at very extreme values, or having extremely high tolerances for potentially accepting the null. Yeah. So that I think is pretty interesting. That this population of users that we're looking at seems to have a very high score on the sleep apnea survey. So we've gone over a t-statistic. We've gone over a pretty simple t-statistic. Now what I want to do is cover a one-way ANOVA. And if you watch the earlier video, what you will know is we do one-way ANOVA or F-test when we want to compare multiple means. And so what we're going to do is we are going to look at our sum score, and then we want to look by something that has multiple factors we can look at. And for that, I'm going to use pillows, and that's just how many pillows the patient sleeps with. Okay? And so let's take a look at some of these options. Yeah, I don't think you're really going to need different types of interpolations. These are sometimes things you might want to look at, that for instance, you might want to adjust for how many types of comparisons you're doing, or what type of variance assumptions you're making. But again, I think that's beyond the scope of the course. But what we are going to do is we are going to look at, we probably want to generate descriptive statistics. we also might be interested to understand if there's any heterogeneity, but let's leave that out. I would like this means plot though, because I suspect it might be informative to sort of visually see that difference. Okay, and then there's this thing called Bootstrap, which I'm not going to go into too intently. But what you should know about a bootstrap is it's this statistical approach where you can generate sampling distributions by repeatedly sampling from data you've already collected. And what that will do is, for instance, if you want to compute standard errors, but you don't think your data is particularly normal or fits one of the distributions we already have, what you can do is you can randomly sample with replacement from the data you already have to generate your standard errors. But again, that's sort of a brief aside. So that being said, let's generate our one-way ANOVA. And what did I do around here? What? I used the pillows variable, I believe, instead of the num pillows variable. So let's do this again. We're going to go to our one-way ANOVA. So we're going to swap out pillows for num pillows. And now we're going to press OK and see what that looks like. And actually, so what we see is that individuals who used 0 pillows actually had slightly higher scores, that they had an average of around 25, whereas individuals who used 1 pillow had slightly lower sum scores on the assessment. And finally, individuals who used 3 pillows actually had the least, the smallest sum scores on our assessment. Now, that is interesting. It actually appears to be rather linear in terms of how much they decrease, that as you gain more pillows, you exhibit less sleep apnea. And again, what we have here are we have our means, our standard deviations, and our standard errors, as well as our lower and upper bound confidence interval. But what we really need to look at is our ANOVA and our statistical significance. And what we see here is that these are between group sum of squares errors. So again, I don't want to get too much into that, but what you do want to look at is your associated F statistic, and particularly this significance feature. And what that significance indicates is whether or not there's a statistically significant difference between these groups, meaning do we think that it's more likely that the mean for this group is all the same, or do we reject that hypothesis and believe that at least one of these features have a separate mean? And when we look at this sort of mean plot, I would have been tempted to think that, you know what, there's this nice solid relationship with the number of pillows. You see decreases in the sleep apnea assessment, but apparently not. So we failed to reject that there's no relationship between the number of pillows that an individual uses and how likely they are to score highly on the sleep apnea assessment. So we're going to pause real quick. All right. Well, the third thing I wanted to show you was we just did our test of means. What I wanted to show you is, can we sort of assess whether or not there are relations between categorical data? So what we're going to go to is we're going to go to data and crosstabs. And again, there's no shame in not being able to identify where these sort of analyses live. Takes time, and it takes some time to memorize. So we're going to go to descriptive statistics. We're going to go to crosstabs. And one of the things I'm interested in are whether or not there's any relationship between whether or not men use different amounts of pillows than women. So what I'm going to do is I'm going to put my rows and my columns assign male and our male indicator to our rows, our columns to the number of pillows variables, and then we're going to go look at our statistics. And one of the things that I want us to do is calculate that sort of chi-squared statistic to see if there's any relationship. So we go, we click OK. And what we see is we've got our N, 120. Here is the breakdown of how often females use certain types of pillows, same for men. And one of the things that we're now looking into is whether or not these relations are independent. All right, so we have these associated values, and we have the asymptotic significance. Again, these are two-sided tests. And what we see is that our associated significance, or p-value in this case, is 0.235, suggesting that we fail to reject the hypothesis that these gender and the number of pillows that individuals use are completely unrelated. So the next two things that I want to show you are linear and logistic regression. And so linear regression is like a correlation, except we are potentially modeling multiple variables. So what we're trying to predict here is, in this case, is we're going to try and predict AHI. That measure is just how many times an individual stops breathing per hour. And what we're going to throw in as that sort of sleepiness assessment we used earlier. And what we want to do is we want to see our estimates, our coefficients, our R squared, and let's see. Let's press OK. And the nice thing is, again, SPSS is really clean about sort of communicating what assumptions it's making. And it actually reports model statistics here first. And what these statistics correspond to are R, which is just the correlation coefficient we talked about earlier, and some variance of it called R squared, which is a more common measure to describe how much our regression model explained variance compared to the total sum of squares variance. And finally, we have our associated F statistic. Again, just sort of suggesting how significant our specification is. Because it's very low, we think our model choices or what we threw in as coefficients makes sense. And going to our actual coefficients, again, what we're doing here is we're treating things as a linear model. So we're just trying to generate a line that will go through a scatter plot of our sum score and an individual's AHI. And the nice thing about linear regression is it's nice and interpretable. So for instance, we know that if an individual had a sum score of 0, then our associated guess of what their AHI would have been would be around 15. Conversely, this coefficient on sum score corresponds to a slope coefficient, meaning that as an individual reports higher and higher sum scores, they're more likely to report a higher AHI. And the way we can interpret whether or not that's statistically significant is the same way we did with our one sample t-test. What we do is we look at our associated t statistic, which is around 13, and right next to it we have our significance value. And because it's so low, they actually report it as 0, even though it's something that's infinitesimally small. And we've got our associated confidence interval, suggesting that while we don't know the exact estimate of how sleep apnea increases as an individual's sum score increases, we feel reasonably confident that it's somewhere between 1.4 and 1.925. All right, so the last thing I'm going to do is show you a different type of predictive model called logistic regression. And what we're going to do is we're going to see if we can predict, say, a person's gender based on their AHI. So what we're going to do is let's actually, you know what? I think this is enough for today. So I'm going to pause here. You also have supplementary reading as well as videos that covers things outside of the scope of this lecture. So I would encourage you to take a look at those as well. And I don't want you to feel too overwhelmed with problem sets. So we're still gonna use the pre-existing lecture and exercise, but I just want to make sure that you have a little bit more exposure to significance testing, because that is really important. What I would like to do is show you, now, you know what, you've had enough for today. Thank you so much, and I look forward to seeing you on Tuesday. Take care.